When you're working with trigonometry on right triangles, the three sides of the triangle have special names. The hypotenuse of the triangle is the side opposite the right angle, and it is always the longest side of the triangle. The other two sides are referred to as the opposite and the adjacent, but which one is which depends on which angle you're looking at. If we're focused on this red angle here, then this side is opposite the angle, and this side is adjacent to the angle, which means beside it. If we were talking about this angle, the opposite and the adjacent would switch places. So based on those definitions, we have the sine, the cosine, and the tangent are the three ratios that we use. The sine is defined to be the ratio of the opposite to the hypotenuse. The cosine is defined to be the ratio of the adjacent to the hypotenuse. And the tangent is defined to be the ratio of the opposite to the adjacent. There's a simple mnemonic you can use to remember which one is which. Which is SOHCAHTOA. The letters stand for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now let's recall how to use those ratios to solve trig problems. Here's a right triangle for us to solve. We have an angle of 38 degrees. The hypotenuse of the triangle is 12 centimeters, and here we have a side that we're trying to find. Our first job is to decide whether we want to use sine, cosine, or tangent. So let's identify the sides with their special words. This is the hypotenuse, and this side is opposite the 38 degrees. So the ratio that uses opposite and hypotenuse is sine. So this is a sine problem. So the first thing we'll do is set up our sine ratio using the numbers in the problem. The sine of 38 is equal to x over 12. Now we just need to solve for x. If we multiply each side by 12, we'll get x alone. So x equals 12 times the sine of 38. At this point, you simply type that into your TI, making sure you're in degrees, and it will happily give you 7.39 centimeters for the length of x. In this problem, we have an angle of 42 and a side of 10, and the missing side is the hypotenuse. Once again, let's begin by deciding whether we want sine, cosine, or tangent. With respect to the 42 degrees, the 10 centimeters is the side adjacent to it. And as we said, x is the hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. So let's set up our problem using the numbers from the triangle. The cosine of 42 equals 10 over x. Now this time x is in the denominator, so our solving is going to take a few more steps than it did last time. The first thing we need to do is to get x out of the denominator, and the simplest way to do that is to multiply each side by x. So that gives us x times cosine 42 equals 10. Now, in order to get x alone, we need to divide each side by cosine 42, which will give us x equals 10 divided by cosine 42. At this point, we can type that expression directly into the TI, and it will give us 13.46 centimeters as the length of the hypotenuse. In this problem, we're trying to find one of the angles of the triangle, and we know two of the sides. Once again, let's begin by deciding whether we have sine, cosine, or tangent in this problem. With respect to this angle, the 11 is the side adjacent to it, and the 9 is the side opposite it. So looking at SOHCAHTOA, we want tangent for this problem. So we'll fill in the information we have, and it says the tangent of x is 9 over 11. So what we're actually trying to find is the angle whose tangent is 9 over 11. In order to find that, we use inverse tangent. So our statement looks like this. X is the inverse tangent of 9/11. We can type that statement directly into the TI, and it will give us 39 degrees.